Okay students, now we are going to see the course signals and system. Under that the topic is discrete time Fourier transform and its properties. Upon the completion of this discrete time Fourier transform and its properties, the students will be able to apply the DTFT on discrete time signal for solving the engineering problems. Discrete time Fourier transform is the transformation that maps the discrete time signal x of n into the complex valued function of the real variable, namely Fourier transform of x of n is x of e power j omega, that is summation n equal to minus infinity to infinity x of n e power minus j omega n. The inverse discrete Fourier transform is given as x of n equal to f inverse of x of e power j omega, which is equal to 1 by 2 pi integral minus pi to pi x of e power j omega n into d omega. Here the n values ranges from minus infinity to infinity. Example, find the DTFT of x of n equal to a power n into u of n. Solution, the Fourier transform of x of n is given as summation n is equal to minus infinity to infinity x of n e power minus j omega n. Here substitute the x of n value, so it becomes summation n equal to minus infinity to infinity a power n into u of n e power minus j omega n. Here n is common for a power n and e power minus j omega. And u of n means the x of n exists only n is equal to 0 to infinity. So change the summation limit is limit from 0 to infinity a e power minus j omega the whole power n, that is equal to 1 divided by 1 minus a e power minus j omega. Second problem, find the discrete time Fourier transform of x of n equal to a power modulus of n. Here modulus of a value should be less than 1. Solution, x of e power j omega equal to summation n equal to minus infinity to infinity a power modulus of n u of n e power minus j omega n. So modulus of n represent the n hold both positive and negative value. So based on that we have to split the a power n term. So summation limit n equal to minus infinity to minus 1 x of n is a power minus n into e power minus j omega n, and if the limit is from 0 to infinity x of n is a power n into e power minus j omega n. Now in the first term of the summation replace minus n by m, so we get summation m equal to 1 to infinity a power m into e power j omega m plus summation n equal to 0 to infinity a power n into e power minus j omega n. So the inverse forward transformation of first term is a e power j omega by 1 minus a e power j omega, and the DTFT of the second term is 1 by 1 minus a e power minus j omega. On simplification we are getting 1 minus a square by 1 minus 2a cos omega plus a square. The properties of discrete time Fourier transform. Linearity property, the Fourier transformation of x1 of n plus Fourier transformation of x2 of n, that gives x1 of e power j omega plus x2 of e power j omega. Time shifting property, the Fourier transformation of x of n minus n naught is equal to e power minus j omega n naught into x of e power j omega. Here a proof, summation n equal to minus infinity to infinity x of n minus n naught is e power minus j omega n, that is equal to summation m equal to minus infinity to infinity, replace n minus n naught by m, so x of m e power minus j omega m plus n naught. So n naught is the constant term, so we keep it outside. So e power minus j omega n naught summation m equal to minus infinity to infinity x of m e power minus j omega m, that is equal to e power minus j omega n naught into x of e power j omega. Time reversal, Fourier transformation of x of minus n is x of e power minus j omega. Convolution, the Fourier transformation of x of n convolution y of n is x of e power j omega into y of e power j omega, that is g of e power j omega equal to summation n equal to minus infinity to infinity and summation m equal to minus infinity to infinity x of m y of n minus m into e power minus j omega n. So split the summation, so summation n equal to minus infinity to infinity x of m and summation m equal to minus infinity to infinity y of n minus m into e power minus j omega n. Here we make a substitution. N minus m is replaced by r, so n is equal to m plus r. So the summation m is equal to minus infinity to infinity x of m, and summation r equal to minus infinity to infinity y of r e power minus of m plus r omega. So split the term. Summation m equal to minus infinity to infinity x of m e power minus j omega m, and summation r equal to minus infinity to infinity y of r e power minus j omega r. That is equal to x of e power j omega into y of e power j omega. Frequency shifting. The Fourier transformation of e power j omega naught n into x of n is x of e power j omega minus omega naught. Time multiplication. The Fourier transformation of n into x of n is minus z dx of z by dz. Here the z is equal to e power j omega. Parshall's theorem. X of n convolution x of n into y conjugate of n is equal to 1 by 2 pi integral minus pi to pi x of e power j omega into y of y conjugate of e power j omega into d omega. Proof. 1 by 2 pi integral minus pi to pi, then summation y of x of e power j omega value substitute. So n equal to minus infinity to infinity x of n e power minus j omega n into y conjugate of e power j omega into d omega. So interchange the summation and integration. So summation n equal to minus infinity to infinity x of n 1 by 2 pi integral minus pi to plus pi y conjugate of e power j omega into e power minus j omega into d omega. For the easy case, we have to make an assumption x of n is equal to y of n, and the Parshall's theorem becomes summation n equal to minus infinity to infinity modulus of x of n the whole square is equal to 1 by 2 pi integral minus pi to pi modulus of x of e power j omega the whole square into d omega. Then multiplication of a sequence. So Fourier transformation of x of n into y of n is equal to 1 by 2 pi into y of e power j omega convolution of x of e power j omega. Proof. Replace y of n by inverse Fourier transformation, and summation n Fourier transformation is given as n equal to minus infinity to infinity x of n. So y of n is written as 1 by 2 pi integral minus pi to pi y of e power j omega. Omega is replaced by lambda, so y of e power j omega j lambda e power j lambda n d lambda into e power minus j omega n. Then which is equal to 1 by 2 pi integral minus pi to plus pi y of e power j lambda d lambda summation n equal to minus infinity to infinity x of n e power minus of omega minus lambda into n. That is equal to 1 by 2 pi integral minus pi to pi y of e power j lambda into x of e power j omega minus lambda into d lambda. That is equal to 1 by 2 pi y of e power j omega convolution of x of e power j omega. Differentiation in frequency domain. That is dx of e power j omega by d omega is d by d omega of summation n equal to minus infinity to infinity x of n e power minus j omega n. Differentiate this, so we are getting minus j summation n equal to minus infinity to infinity n into x of n e power minus j omega n, that is equal to minus j Fourier transformation of f of n into x of n. Quiz. Given that w is equal to e power minus I 2 pi by n, where n equal to 3, f of w power n can be computed as f is equal to 1. Thank you.